Gee, I'm a tree.
Okay, so our next transformation we're going to talk about, third one, is rotation, and that's the most complicated of the three transformations. I mean, sorry, the four transformations we're talking about. So, rotation, you should know, you twirl yourself around a lot, you rotate. Um, but a formal definition is that it moves the point in the coordinate system around another fixed point. And typically in this course, the fixed point we're going to be talking about is 0, 0, the origin. Now, some common rotation we talk about is the rotation of 90 degrees of xy is going to become negative y x. And the problem with this whole rotation thing is that it's the most complicated one to be able to just sort of look at and figure out. So one thing you just sort of need to do is memorize these. There's really no way around it. So what we can do, you can memorize that it's xy is going to become negative yx. And what you're going to do is, what you're really doing is switching the x and y value and then negating the new x value, the first one. So, another common transformation is a rotation of 180 degrees of xy is going to become negative x, negative y. And you're going to keep x and y the same, negate them. Now, the last common rotation is the rotation of 270 degrees of xy. It's going to become y negative x. You switch them, and now you're going to negate the new y value, the x value, where it was. Okay. Now, one other key thing to remember, there is a fourth rotation that you typically see, but it's really the same as one of these. So, the rotation of 270 degrees can also be represented by negative 90 degrees. If we're talking about the signage, positive means that you're going counterclockwise. Negative means you're going clockwise. Okay? So if I have a circle, there's 360 degrees in there. If I get 270 degrees all the way over here, and then if I go 90 degrees the opposite direction, the negative direction, you're going to end up at the same point. Well, hence the reason that they are actually the same rotation. So when you see negative 90, think of 270 degrees. Okay. Now, let's take a look at some examples. Find the result of the rotation of 90 degrees on negative 3, 4. Now, negative 3, 4, rotation of 90 degrees, we switch the x and the y value, and then you're going to negate the first one. Okay? So you get negative 4, negative 3. That's it. Key thing is you need to memorize these rules. Now, find the result on the rotation of 270 degrees on 0, 3. What you do, you switch the x and the y again. And in this case, for xy, it's going to become y negative x, meaning we're going to negate the second one. In this case, it's special because 3, 0 is actually, the zeros you can't really negate since it's not a positive nor a negative number. So that's your final answer. Now, find the result of the rotation of 180 degrees on negative 1, 2. Remember, we keep the x and the y the same spot, but we negate both of them. So negative is going to become a positive, and the positive is going to become a negative. And that's your final answer. Okay, here's some problems to work on your own. If you have any questions, we can discuss tomorrow. Talk to you later. Bye-bye.